Sometimes when we multiply two binomials, we end up getting a polynomial with four terms. So there are no like terms to combine. If we have a polynomial with four terms and we want to factor it, and there's no greatest common factor between the terms, what we want to do is get those binomials back. So let's see an example where we multiply two binomials. And even though we have shortcuts for this, I'm going to do this by applying the distributive property twice, because I want us to look at just how that looks. So what I'm going to do here is, first, I'm going to distribute to the right. So I'm going to say I've got 2x minus 3 times 3y plus 2x minus 3 times 4. And now I'm going to distribute to the left. So I'll have 2x times 3y is 6xy. Negative 3 times 3y is minus 9y. 2x times 4 is plus 8x. Negative 3 times 4 is negative 12. And there are no like terms to combine here. So I'm done multiplying that out. We ended up with four terms in the product. How could we go through this process backward? Get back to the beginning and find out about the 2x minus 3 and the 3y plus 4. Well, here is that polynomial. So let's see how we can attack that such that we get our two binomials back. The first thing I want us to notice is that when we did that multiplication, we had these two terms that came from distributing to the left once, and these two terms that came from distributing to the left a second time. Let's see what happens if we group those terms together. So this was my given polynomial, and now I'm going to use the associative property to group my first two terms and group my second two terms. And when I do that, the thing I notice is that these two terms have a common factor. These two terms have a common factor of 3y. What's left of this term? 6 divided by 3 is 2. Xy divided by y is just x. Minus 9 divided by 3 is 3. Y divided by y is just nothing. So just 1, really. So I factored out the greatest common factor of 3y from this first binomial. The second binomial, I see a common factor of 4. 8 divided by 4 is 2, so we've got 2x. Negative 12 divided by 4 is 3. So we've got, hey, 2x minus 3 again. So I notice when I do that, pull out the common factor, that the binomials I get are identical. So what have I just done? I factored out the greatest common factor from each pair of terms. But now I see that I have a common 2x minus 3 that's being multiplied by a 3y and a 4. So now I'm thinking that I'm factoring out the 2x minus 3 as if it were just one thing. So I'm doing the double distribution backward. And that gives me back my original two binomials, as expected. Okay, so how do we go about this process? To factor a polynomial with four terms by grouping, first we use the associative property to group the four terms into two pairs. For each pair, we factor out the GCF. We notice that the remaining binomial factors are the same, so we factor that out to write our polynomial as the product of two binomials. If we want to check that that worked correctly, we can multiply it out and confirm that we get the original binomial back. If we want to check that that worked correctly, we can multiply it out and confirm that we get the original polynomial back. We didn't do that in the first example because we had already done that multiplication. In this next example, though, we are actually going to multiply out and confirm that it worked. So let's factor 2y cubed minus 3y squared minus 10y plus 15. And there's a complication here because there's a bunch of subtraction. And remember that subtraction is not associative. So if we're going to group the terms, we need to make sure that that middle operation is addition. So instead of minus 10y, I've written plus negative 10y. And now when I group the terms, I have addition in the middle. In this first pair, 2 and 3 have no common factors. Y to the third and y squared. I think y squared is the lower power, so y squared is the greatest common factor. 2y cubed divided by y squared is just 2y. Negative 3y squared divided by y squared is just negative 3. Now, in the second binomial, I want to get a positive leading term. So I want to divide this negative 10 by a negative 5. And now I've got negative 10y divided by negative 5 is positive 2y. Positive 15 divided by negative 5 is negative 3. And now I stop and notice that my two binomial factors are exactly the same. If they weren't exactly the same, I could not continue with this. So I'm going to have something times 2y minus 3. What's the something? The first term is a y squared, and the second term is a negative 5. And again, let's confirm that when we multiply that out, y squared minus 5 times 2y minus 3, we actually get our original polynomial back. I'm multiplying two binomials, so I'm going to use the FOIL shortcut. Y squared times 2y is 2y to the third. Y squared times negative 3 is negative 3y squared. Negative 5 times 2y is negative 10y. And finally, negative 5 times negative 3 is positive 15, which is my original polynomial. As you practice factoring, it is a good idea to multiply out and check that your factoring worked correctly. It's a good habit to be in, and it will catch most mistakes that you might make.